Hello, my name is Garrett Cohen. I am a wildlife biologist from the United States, and I am happy to be speaking about population dynamics of an invasive cactus using multi-temporal aerial imagery and machine learning. I hope you come away from this with a greater understanding of the method applied here and that you may also use it in your own work. Let us begin. For you to understand this project, you need to understand its purpose. The utilization of machine learning for the monitoring and management of invasive plant species creates an opportunity for us to streamline environmental efforts, as the application of this tool is meant to reduce the large amounts of time which are spent in identifying invasive species and keeping track of their growth and spread. It's also hoped that in the future the methods applied in this project can be applied to other invasive plant species. Now, to reach this goal, this ongoing project explores the effectiveness of utilizing public aerial imagery from sources such as Google Earth for training effective deep learning data. This would allow for an alternative option for scientists to acquire data instead of having to spend money on expensive aerial imagery. While also the project is meant to lead to a better understanding of Opuntia populations as a way to better manage and control them. To the general public, they may wonder why all the effort is given to trying to combat invasive plant species, as they might not see the initial problems they present in the long term. Invasives can contribute to a loss in biodiversity through outcompeting native species for resources, or even modify the habitat in a way to make it difficult for native species to continue flourishing, or impact economic industries such as agriculture, damaging the livelihoods of communities. They may even affect the health of people, whether acting as a vector for disease transmission or injuries through poisons, toxins, or simply puncture wounds. The traditional methods of monitoring and controlling invasive species can be difficult and limited. Human error is always a constant, but with plants it can be exacerbated through easily misidentifying different plant species because of their similarities or being unable to spot them in dense areas. The amount of time consumed makes it difficult for maintaining the most up-to-date data on areas, along with trying to meet deadlines which may seem realistic at the moment but are pushed back because more time is needed, because other factors may have influenced the amount of time needed to complete the surveys. Plans can also be disrupted or changed completely based on weather, making a project that could have been completed in 3 days go into a full week. For the materials utilized in this project, an invasive plant species was of course needed. So the Opuntia genus was chosen, also commonly known as the prickly pear cactus, as its unique anatomy allowed for more effective troubleshooting in terms of improving the model being made for detection. For example, if a model misidentifies a plant that is not Opuntia, it is easier to make the determination of whether there needs to be more data, the image is not clear enough, or if the limits of the deep learning tool have been found. This would be harder to make these distinctions if the invasive plant subject had the more generic plant look, instead of the unique shape the cactus has. Opuntia was also selected as 2 species of the genus are invasive to the Mediterranean basin, which go as Opuntia ficus indica and Opuntia stricta. The main tools which are used in this project are QGIS for mapping, along with ArcGIS for deep learning. Once the data was collected in those areas, Excel was utilized for creating graphs to display the temporal data that we acquired. The study area where the data was collected was in an area in Greece. It was selected for its high density of Opuntia, which was determined by using other tools such as iNaturalist. Other factors play in the selection of the area, such as how easy it was to reach, such as its proximity to roads, along with how easy it would be to traverse the landscape. A diverse climate was also sought after, as it allowed for a better understanding of how the invasive Opuntia in the area are affected by different climates in a land foreign to it. Aerial images were also collected using a low-flying drone to take pictures for further study. And as you can see in Figure 3, this study area, this is an aerial image that was acquired through Google Earth Pro. These are the aerial images taken from Google Earth. The images used here show the same location over the course of several years. If you look at the blue outline, you can see the Opuntia. This is to demonstrate how effective the tool can be used for monitoring changes in invasive plant populations over the years, along with taking it a step further and utilizing data for training a deep learning model. Even though not every image will be as high quality, there is still a significant number which are able to be utilized. Now let us discuss how this method is actually done. The challenge of tracking and managing the spread of invasive species can be met with multiple difficulties and challenges. To solve those problems and streamline tasks, which would normally eat up most of your time, a combination of machine learning and spatial mapping to monitor and predict invasive species movement is applied. One of the first things which needs to be done is to collect the necessary aerial imagery with the highest resolution on Google Earth Pro. Supplemental UAV images are also gathered from past visits to study area to use as additional training data. The opuntia on these images are then segmented by AI to be prepared and turned into a deep learning model by utilizing machine learning tools through ArcGIS and QGIS. After this, we check the survival distribution and size of individuals over time. The opuntia are segmented through the use of an open source model called the Segment Anything model to create the necessary training data. The data can then be run through the image classification tool in ArcGIS, so it may be ready for training into a deep learning model. ArcGIS possesses several tools which assist in the creation of models, with the first being the Train Deep Learning Model tool, which will take the end result and be put into the next tool called the Detect Objects Using Deep Learning, which will finally identify any opuntia on an aerial image the tool is used on. The goal for the paper this presentation is based on is to create a model that can achieve an accuracy rate of at least 86% or higher. The paper for this project is ongoing, but I wanted to share some interesting results which were acquired so far and will be further explored in the near future. When testing the models out, it was found that the success of the model was dependent on several factors, such as the rotation of training data, as this form of data augmentation creates more data to be added for training. The size of epochs and batch size plays an important role in determining the number of training samples used in an iteration, along with the number of times the data sets will pass through the algorithm. This all coalesces in the creation and accuracy of the model. In Figure 7, a model applied to a small aerial image, you can see that the model was successful in identifying a majority of the opuntia in the area with an average precision score of 69%, demonstrating that the methods applied have promise and can be used. The results relating to size and age of opuntia from this study are rather interesting. If you look at Figure 8, you can see that the graph shows how the oldest of individual opuntia are diverse in their size, while younger ones have a limited range of size differences. This could suggest that older opuntia are able to become bigger, but that does not mean that they will, and it's something to take into account that would prevent misidentification of older opuntia being younger based on their size. And even though the methods being applied are meant to be easily available and more open source, there is the issue of processing power. The amount of data being processed requires a computer with a strong GPU for effective and efficient work. The research conducted has revealed unique information relating to the opuntia study area and how they change over time. If you look to the left, a graph shows an increase in population over time, which shows the still impending threat of invasive species, but also suggests the possibility of them becoming more clear on Google Earth because of the growth in their size as a possibility. The other graph reveals the connection between the age of individuals and their frequency, with a significant amount of older opuntia compared to young ones, suggesting reproduction is not occurring as often as it would be assumed for an invasive species. This is a map of all the opuntia identified in the study area. What's interesting about the results is how even after all these years, there's still a larger population of opuntia 7 years older than there are of new ones, indicating how the reproduction is not occurring at a fast speed. I think it is also important to notice is how most of the diverse age ranges are focused in this center, while there is only a small number at the top. suggesting that certain environmental factors such as perhaps urbanization are preventing its growth and spread. In conclusion, the use of open source satellite imagery combined with machine learning provides the user with an innovative opportunity for invasive species management and study. Through the application of this method and its tools is a great deal of potential for large-scale monitoring as well as predicting the expansion of invasive plants for management purposes. The quality data collected would remain the same or even better while saving time to be utilized in other endeavors, while reducing reliance on expensive aerial imagery. This tool will provide a practical tool for everyone in our field and can lead to a better understanding of invasive plant populations. What comes next for this project is to utilize the deep learning pipeline to see if the cacti survive or not over time and also create the most optimal model for 𝙊𝙥𝙪𝙣𝙩𝙞𝙖. Thank you for watching. I hope you have found this presentation interesting, and I hope you may be able to apply a version of this method to your own work. Have a good day.